Hi, my name is Olukunle Owolabi. I'm a PhD student at Tufts University, and I'll be talking about the data-driven application of modern portfolio theory to the electrical grid. This work is under the umbrella of the PRISM project. Um, and here are the contributing authors. Here's a quick outline to what I'll be talking about: introducing the modern portfolio theory, next the data used, and the Effender-Ishman index for measuring diversity. I'll talk about that later, and a short conclusion. What is modern portfolio theory itself? It's basically a way to, understand like the risk and return relative to like the level of diversity. So this metric is abstracted from the finance domain, and in general, what happens is that there's a risk return trade off where the higher the risk, the higher the returns, and vice versa. So the main objective of this study, it's much more a methodological study where we're trying to see how we can use this same approach and transfer it to electrical grid context, trying to use knowledge of the financial world of diversity and how you can diversify to try to understand how risk can interact or propagate in the electrical grid. Quick introduction to the context of the electrical grid, since we're using this approach to sort of understand the electrical grid. Here are the distinctions, things that we're comparing it to in the electrical grid. Usually you have things like assets in the financial domain, but here we've considered the generation as the asset. And in terms of returns, that we have in the financial domain, we have the for the electrical grid, we have the reliability, like because that is what we're trying to optimize. We want to get more returns, but in this our case, we want to get more reliable grid. So are we that's sort of like the comparison of the context. Yeah, here's a quick overview of the data we used. Data is collected from the Office of Energy and Environmental Affairs in Massachusetts. The resolution is city or town and sometimes street. So essentially, we calculated a way of quantitatively measuring the impact of an outage, and we found a robust way, which is COH and SAIDI, which you have here. So COH is basically a product of the number of customers affected and the duration of the outage. I won't go into too much details here. Feel free to pause and look into the data we have. This is the New England data on the generation mix, which we're going to use to calculate the Effender-Ishman index, which is a predominantly financial index that we're applying to the electrical grid. Here is how the data looks like. We have the fuel category, different types of fuel: coal, hydro, natural gas, and all others. But this is basically the format and how the data looks like. The Efrindal-Ishman index is the indices we'll be using here. It's abstracted from the finance domain, and basically we're just trying to apply this to the energy domain. Essentially, IHHI indicates that you're moving towards a higher concentration rate, and here is the formula we've used to calculate HHI. Here we're showing the relationship between the HHI, which is a measure of diversity, and COH, which is a measure of the severity of an outage. Here we don't have much of a strong relationship. However, what we try to show here is that the methodology, can be applied to, to give an insight into the relationship between, HHI and COH. But looking at it, we kind of have a slight positive correlation, and that indicates that increase in HHI, which is increase in concentration of generation, could lead to a slight positive increase in the outage or severity of an outage, and that's practically what you would expect in the field. Yeah. A general conclusion from our work is that we have tried to show the interesting insights for applying sort of the modern portfolio theory framework to the electrical grid. Um, we believe that there's more room to unlock some insights into risk in the electrical grid using these metrics such as HHI.